All right. So starting at samsclass.info, you click cryptography, and you get here to these cryptography projects. And there is a binary games. I imagine you folks all know binary. Most of you have taught Cisco, so you probably don't need these. I just made a simple sort of JavaScript-based game so you can practice doing various binary operations. And that's a good place. A lot of people start here, and it's just an easy way for students to practice that stuff. But the thing that I think is more directly useful is CrypTool. Just a couple of these require Windows. And there's this tool, you can install it on Windows. It's a free tool, and I've got it here. Okay, this thing is CrypTool. And this was written by German bankers trying to teach the basic elements of cryptography to banking students. So it's really kind of appropriate for our students. And it makes it easy to do simple cases to understand how basic cryptographic operations work. So here you can use I'm only going to use the wizard. That's the simplest way to do it. And then you can do cryptanalysis next. And then you've got classic and modern encryption. And we're going to, in the projects, you try some of each. The classical methods are, of course, the old ones, basically from before computers. So they're all too simple to protect data anymore, but they were considered good encryption in the past, like the Caesar cipher, which was military-grade encryption 2,500 years ago, when people could barely read at all. Scrambling the letters even a little bit was considered strong encryption. And so you can put in a message here, like, hello. Some kind of message, and it can be in English. All right. And then, well, this is Caesar analysis. Pardon me. Let me just go back. I thought I was in the encryption part. In the analysis part, it's going to break the cipher, so you have to have properly encrypted stuff. So let me just make a new wizard because my overriding that is not going away. So let's go to cryptanalysis. Next. Classic. Caesar. All right, and here it has some ciphertext in German. And so it's unreadable now, but if you go next, it will decrypt it, which is extremely easy because there are only 26 possible keys. I mean, all it's doing is shifting each letter forward in the alphabet by a certain number of steps. So there's only 25 or 26, depending on how you count it, possible values. So it just tries them all. And then to determine when it's right, it uses letter frequency. And since it knows the letter frequency for German and English and a few other languages, it knows what letter should be the most common. In German, J is the most common letter. In English, E is the most common letter, and so on. So it's pretty easy to shift it until the pattern of frequencies is close to the expected value, and then you know the right shift, and then you can decrypt stuff. So there's stuff to decrypt. And I think I have an example here. Yeah, here's one. I put up an example to show you. This is a in Caesar shifted quote. And so if I want to decrypt it, I can go back and put it in here. There it is, and it's English. You have to tell it the language because it needs to know what the letter frequency is supposed to be. And now it will decrypt it. And there it is. It's a quote from Abraham Lincoln. And all it had to do was move the letters by 3 in the alphabet. So it's very easy to understand how this works. And you see the most common letter is H in my ciphertext, so that should be E, moving 3 letters to the left. Next one should be T. T is missing. Okay, anyway, here's T, 3 letters past T. So anyway, that's the thing. That's how it works. So that's the Caesar cipher. And you can do other things here too, like you can do stronger ones. For example, substitution cipher, where you don't just shift all the letters forward in the alphabet, but you substitute letters with other letters according to some pattern. That is the monoalphabetic substitution. And so here's a English ciphertext of some kind, and it's quite unreadable now. But when you want to decipher it, it's going to figure it out and see in cryptography, a substitution cipher is a method. It figured it out. And if you go down here, I guess it's not going to show us any details anymore. It's going to show it tried 32,000 keys. I mean, by the way, in principle, there are an unthinkable number of substitutions, like 26 factorial, possible ways to replace every letter with another letter. But in practice, it's not that hard because all you do is find the most common letter, and that's probably E. Use frequency analysis again. So you don't have to try that many. But that I've got another example here, though. And one thing I wanted to show you is one way I thought students might do this these days is by using large language models. That would seem like an obvious thing to try. So I tried a few of them, and the results were pretty interesting. So let me move this over here. So here's the first one, which was encrypted with the Caesar cipher. So I copy that. I think I might just be able. I put that in a few large language models like this one. This is Perplexity. And so when I tell it to decrypt that, it immediately gets it. The exact quote from Abraham Lincoln, and says it's the Caesar cipher. So the large language model can easily do that. But when I try the substitution cipher example, which is down here, all these capital letters, this is a sentence with a substitution cipher. And I think it's real important to understand what large language models do here. If you say, decrypt this, okay, and run it, it will tell you an answer. This is just a few of the ways we should. There were crucial weapons that, and so on, would help the children any way they could. All right, so it's got strange, and if you just go to Gemini, let me get the whole query here and run the exact same query. So that's Perplexity. Here's Gemini. Let's go down to the bottom and put it in. Things are going on here at the warehouse. We found a hidden room full of treasure. Seems like someone is hiding it all along. This is the important thing to understand about large language models. When they don't know how to do something, they just lie. Because this is why I think people need to understand how these things work. All it did was take this prompt, turn it into numbers, map it into space, start a curve, and project the shape of the curve and just move forward. It has no way to know whether what it's saying is true or false. So it will always give you an answer. It will just be a random, stupid, wrong answer presented with apparently complete confidence. And here's Microsoft Copilot. If I just go to Bing and I go to Copilot and give it the same thing, we'll see what it does. I seem to have to refresh it to get it to take something. All right.
What if you ask it to evaluate it first and determine the type of cryptography it is, and then ask it to decrypt it?
That's a good idea. That's the step-by-step method. Let's see what happens. It's struggling. There we go. Using the ROT13 cipher, it did that. Well, it's at least not lying about what it did. But all right. So let's try that. And for some reason, I always have to refresh the page for Copilot to let me type in new data. Anyway, okay, evaluate this ciphertext.
Yeah.
All right, let's try that. And then paste in this stuff, and I'll get rid of that.
Yeah.
And I'll put the whole thing in a clipboard so I can try it in the other engines. Okay, let's see what it makes of that. A Caesar cipher, which is completely wrong and presented here as if it made sense. Okay, how about Gemini? A Caesar cipher. And here's Perplexity.
Is Perplexity free?
Yep.
Has a free version?
Yep. And there we go. They all just say it's the Caesar cipher. But what's interesting is by shifting the letters back 13 positions, we have this, which, by the way, is completely false.
Yeah.
Not decrypt by the Caesar cipher. And this is the thing that I think people misunderstand about large language models. It will give you an answer that looks really good and just be 100% false. So that's a thing to be aware of. And let me try running that one through the CrypTool, which is, of course, actually going to try to decrypt it. So if I go here, I go back. All right, if I put that stuff in here, okay, and let's get rid of this first line, which was not ciphertext. Okay, let's see what CrypTool does with that. And see, it's having to work pretty hard trying millions of keys and succeeding after trying, I think, 4 million keys. At 105,000 keys per second, it now successfully deciphers it. And it found, and that's the point, it had to find all of this. This is what A, B, C, D, E is traced into. So it had this really quite a complicated job there. But since it can use letter frequency and it knows it's in English, it can pretty quickly narrow down the list of
Well,
possibilities.
and you also told it what kind of
Yes, I
encryption
yeah, I
used.
told it that it was a substitution cipher. That's right. It didn't have to guess that.
Right. So there's two things I would be interested. If you stuck it in the Caesar cipher, what would you get?
Oh,
You
sure.
know,
Let's try that.
and then also if you told the AI that it was a substitution, would it do it?
Those are both good questions. Let's try them. So if I tell it it's a Caesar cipher, it will probably do the same thing the large language models did. It will find the shift that makes the most common letter work and not care that nothing else worked.
I'd be interested because they came with different answers for the substitutions.
Yeah, let me try this. Yeah, let's see. That's a good thought. Cryptanalysis. Next. Classic. Next. Caesar. Okay, let's put it in here. English. Let's see if I have that extra sentence at the start still. I do. Let me get rid of that. And I'm going to put I'm going to put it in the clipboard that way so I don't have to do it. All right, let's see what it does to this. The Caesar cipher. And so it, like I thought, the most common letter is F. So it uses a shift of 1 to make the probability appear to match as well as it can. And then it's done. And then it doesn't notice or care that this makes no sense.
Right. It doesn't understand words or the numbers to create words kind of a thing. So it doesn't.
Well, it does have like an entropy measure. So it might have, the other models might have noticed that this is not good English, but it did the most probable Caesar cipher shift.
Right.
Is what it did. So so I like your other idea. Let's try those AI models again and tell them in more detail how to solve. So let me try a new thread and say this, why it's not taking my typing here. This text is encrypted with a substitution cipher. All right. Whoops. All right. All right. So when I hit enter,
Yeah,
it interprets that as time to go. It doesn't. I have to press shift enter to get to the next line or something. So let's see if I can somehow construct the correct stuff here. Nope. Looks like this copy didn't work. Right click, copy, paste. There we go. Now shift enter. There we go. Now I finally got the correct prompt for these guys. All right, let's see if it can do that. Well, frequency analysis is a good start. Oh, good. This is the right procedure. It guesses a few of them. And now it seems like it only did like the first most common letters though. And ignored, oh no, it's doing more, looking for the, oh, there we are. And it's considerably wrong. It's getting about half the words right and half of them wrong. And it doesn't mind at all even getting something that's the wrong length. I don't think this is long enough to be the word religion. Just that's the thing about these substitution ciphers. They're very far from like the mathematical precision we're used to from computers.
It probably needs an example, or maybe like the chain of thought.
Yeah.
You know what I mean? So I think like you could get there with still working with it.
Maybe, but the surprising thing is, even after it does this, it's still considerably wrong.
I think you could say, you could tell it to like, look at your output for the, the equal variable, apply that to it. Like, so
Yeah.
you could keep working with it and get it there.
Yeah, if you had, I was pretty impressed by its ability to choose like a sensible 3 steps process here. That
Agreed.
that was Perplexity. Let's see what Gemini makes of this. But you're right. If I broke this into smaller steps and did them one at a time, and especially if I told it to like write Python code to do it, then I
Yeah.
might actually get something better. Now here, I can't decipher it. I can offer approaches. Okay, it doesn't even try. It just gives you like a textbook of general information about the encryption process. Okay, this one is still doing one from before. It went on forever. And
Oh my God.
try this one. All right. All right. Here's the deciphered text, and it's totally wrong. Not even any of the words are right. It doesn't make any sense at all. So it just gave me a page from a textbook saying, oh, you want an example of decryption. Here's what an example of decryption looks like. Didn't make the slightest attempt to actually do the problem. So, that's why it's pretty important to understand how these things lie to you and they don't even know the limitations. They don't even tell you when they can't do it. They just randomly spell out the wrong thing. Anyway, so you might like that. I'm going to stop this video for now.